If space travel is on your bucket list, you might be interested to know what it could possibly do to the human body. Our guest on today's Tech Talk, Chris Mason, tells us this and more. So Chris, thank you so much for joining us on Tech Talk. Let's talk about the new space race.
Fantastic. Happy to be here.
Now, we've already done the moon, been there, done that.
Right. It's
now we've got our eyes on
Mars. Mars is coming up, and so hopefully in the mid-2030s, we will have boots on the red planet.
That's pretty soon.
Yeah, it's not that far away. So it used to be science fiction. You'd think, well, maybe my grandkids or my kids' maybe would get there. But we should see it, if all goes well. You know, Elon Musk and SpaceX want to get there within this decade. NASA's described it by about 2035. Also China and India, Israel, many countries now jumping to their feet, including the other ones like ESA and Japan that have already been going to space. Everyone is gearing up to go to space. It's a great new time in space race.
But I got to ask you, what is on Mars? Why do we want to go to Mars?
It's a bit cold, and there's a thin atmosphere.
It's far?
It's very far. It's only about 1% of our atmosphere, so you couldn't really live, and there's not a lot of oxygen there.
What is our obsession with Mars?
Well, we are, by our nature, explorers. Humans have always wanted to explore. I think it's from when we're babies crawling on the floor, putting, your hands and fingers and tongues in light sockets. That's the bad version of exploration, but eventually I think that instinct is innate to humans to see how can we go farther, what else can we discover. But also, if we're on Mars sustainably, we would actually then have a backup plan for humanity. So we don't want to leave Earth. We want to have it be very sustainable and be maintained. But if anything goes catastrophically wrong, it's nice to have a backup plan as well.
Yeah, that's always a scary to think that the backup plan is Mars, but especially the 1% atmosphere that we could, and it's cold, and all of these things that we described. So what we've seen recently in Hollywood is not that far off.
The Martian recently was a great example of seeing, can you actually have someone go to Mars and use current technology, modern methods, and actually survive using recycled stool and urine from other fellow astronauts. So it doesn't sound that clean, but it's actually, you can actually recycle the water quite well. And you could actually do what was done in that movie and survive and grow plants there. There's many research groups working to make plants as well as other cells that could survive on Mars.
And grow potatoes.
And grow potatoes. You could potentially grow tomatoes. There's other, basically oxygen-producing plants, algae that can be engineered. You would need to put them under sort of a protective layer because, again, there's very little atmosphere. The sunlight is farther away from Earth, of course. It has only 36% of the gravity, so the plants would probably grow a little bit taller there, although we don't know yet. But there's not as much gravity there, but they would probably adapt quite quickly, as most life does. And so we think this is not too far off. This should be, in our lifetimes, we might see, vines growing in a greenhouse on Mars.
And do you think it'll be NASA first or a commercial space agency?
So one great thing about the current space race is outside of the billions of dollars being put into it and sort of what's estimated to be many hundreds of billions of dollars a space economy that's coming in our future, is that it's not just Russia versus the U.S. It's not really even just country versus country. This is private versus private and commercial versus government versus even just individuals talking about launching their own companies. So obviously we know about Blue Origin and SpaceX, but Orbital Sciences as well as Virgin Galactic. Many groups just saying, I want my own space company. It's kind of like what you just do now. If you get rich enough, you say, well, I should have my own space company. It seems to be the thing to do. So, and it's because I think it's that instinct. We're all explorers. We all want to know what's there. And there is, of course, a market for it. But so most of these people starting space companies, they're not just doing it for philanthropy. Sometimes some of it is, but most of it is that there is a vision that basically space transit will be much like airline transit is today. That 100 years ago from today, going on an airplane was dangerous and expensive and rare, but today it's commonplace and simple and cheap. And the idea is that 100 years from now, maybe it'd be the same. At least that's what SpaceX is thinking, and others, is that there's a lot of cargo that would have to be moved back and forth. There's things on asteroids that we can mine that are rare metals. There's also a lot of tourism. So all that could be in our future.
Which is a point that you bring up is the tourism.
Yeah.
Have you booked your ticket?
I do not have the $50 million cash to book my ticket to the space station. Not yet. If any.
But come on, you must get a refund for all the work you've done. A refund, at least. A rebate.
I get like maybe a $500,000 discount, maybe. Yes. Or I could say I could do science when I'm up there. But so far, so it's not so bad. It's only $50 million if you want to book a ride to the space station. NASA has recently announced people can book their own ticket. There has been previous space tourism. Space Adventures is one company that offers you just a trip to the space station. And so but now it's actually formally endorsed by Russia and the US. And so it is something that is, if you've got, some spare cash, just $50 million, you can go. And if you can, I would recommend bringing a scientist. If anyone's watching, it's like, oh, I have $100 million that I don't know what to do with. Bring a scientist. It's always good times.
Christopher Mason, he's available for that.
In case needed.
This year, just recently, in April, I believe, or so, you released the results of a study that you were a part of. You led one of the 10 teams that took part in the NASA twin study.
Yes. Yeah.
Tell us about those findings, and also how does this relate to the research you're doing now with Mars?
So the NASA Twin Study, was very honored to be one of the 10 teams that led work on understanding what happens to the human body for NASA's longest ever mission for an astronaut. So spending 1 year in space. Scott Kelly was going to be planning the mission to go up there, and he had an identical twin brother, Mark Kelly, who's now running for Senate, actually in Arizona. So there's a bit of astronaut and political blood in the family, it seems. It was an extremely unique opportunity because we had identical twins, and one could stay on Earth, and one was in space for the longest ever NASA mission, a year in space. And we wanted to bring together the best and most recent technology as well as measures of physiology that we could bring to bear on a human body. So what happens to the DNA, the RNA, the proteins, what happens in the blood, what happens to your microbiome or the microbes in your gut, like cognitive metrics, so how well do they think, as well as the blood work, what happens to the heart and the vasculature, and do this over the course of basically 2.5 years. And so we just released those results a couple months ago.
And these findings that you've just described, I mean, what's the purpose of this? What are you using this for? I mean, to be honest, how many people will be in space in the next, a few decades?
So yeah, to date, the number of people that have been in space is only about 570. So there's really not that many people to study that have even just been to space. It's expected, though, that this will start to increase in the next 5 to 10 years as space tourism happens. So space, if you include just getting just up there to 100 kilometers, we'll see more very short flights. But the long duration missions, where it's 3, 6, 12 months, there's another planned 30 missions from NASA. The ESA and Japanese Space Agency, JAXA, are also planning additional long duration missions with astronauts. So we'll see more of this, but basically this study was NASA's first glimpse into what do we think will happen to the body on its way to Mars. So a year is not quite as long as a Martian trip would be. It would be about anywhere from 6 to 9 months to get there, and you'd either have to turn around right away or stay until the planets realign and then come back. So it could be anywhere from, you're looking at a maybe 15-month mission to 3-year mission, depending on what we do with some of the astronauts. So it was the first chance to see, well, what do we think will the body look like after a year in space or on its way to Mars and on its way back? And so mostly it's good news.
Okay.
Is one of the big takeaways is that the body is extraordinarily adaptive towards really severe stress, including the radiation of spaceflight, the lack of gravity, and really also the change in the food and the entire environment. It's just disruption of sleep. It's not a pleasant environment. It's loud. It's cramped. The microbiome, what's on the bacteria on the skin of all the other astronauts, slowly becomes the same. Some astronauts have shown sign of herpes reactivation because your immune system is suppressed. So some of those are things that are hard on the body, and we see some of the hardship in Scott's body when he was up there. But the extraordinary thing is that almost everything that changed when he got back to Earth pretty much went back to normal.
Oh, including the part about getting a little younger?
Yeah, so some of the genes changed, and they were still changed 6 months later. His cognitive abilities decreased a bit, but they eventually, we think, are coming back up, and his telomeres got longer. So, the good news is when he was in space, one of the measures of aging is how long your telomeres are, the sort of caps at the end of your chromosomes that maintain your DNA integrity. Those normally shrink as you get older, and his got longer in space. So a lot of people say it's like the fountain of youth, except you're being irradiated and you have lack of gravity. So it's a bit disorienting, but he was technically, to some degree, genetically younger when he was in space, but it went away as soon as he got back. So if you want to keep it, you're going to have to stay in space, it seems.
You could pay $50 million for it.
Right. And stay up there.
And how will these findings be used besides looking towards Mars? I mean, you can use them for things here on Earth.
some of the exciting work in the mission is that the technologies that we brought to bear for that study, such as doing DNA sequencing in space for the first time, or protocols to extract blood with very few materials, you can use them in the field for doing infectious disease surveillance, or we're doing some of it at Weill Cornell at the hospital to actually do really rapid sequencing of samples, again, with limited materials. So some of the protocols and methods are helpful for the work that's here on Earth. But then also, we've also launched a company that's looking at measuring everything you can in the body and kind of treating everyone like an astronaut, what we call ONEGEVITY health, which is to track everything you possibly can about what's present in your body and build a trajectory to see if you could actually build a better map of your sort of health trajectory and then customize what you're doing in life or eating or taking to match that.
So this is basically like a startup.
Yeah, so we have a startup in New York City. It's up in Midtown, and it's if anyone wants to have kits sent to them and start to collect samples, it's open for sale.
So it's a startup. So are you still looking for funding?
So we have funding now, so we're not in any rush to get funding, and we have also revenue coming in. We have a partnership that we just announced with Kirin, the beer manufacturer, you probably know in Japan. We're beginning to sell the kits in Japan as well. So we launched in New York City and in the U.S. first. But we're also now beginning to sell in Japan. And so there, the idea is, can you have engineered sort of smart food, smart beverages that would match to your molecular profile and your genetic profile. So we just announced that partnership with Kirin.
Okay, so this is you would know effectively what is good for you and what's not.
Exactly. So ideally you want to have a genetically tailored mixture of probiotics and prebiotics in what you eat, and obviously if you're taking anything else for your food, you want to know the genetic profile of the food, because you are what you eat and you are what you take, whether it's probiotics, vitamins, any kind of supplements, anything you're taking, it will influence your biology and your microbiome or your bacteria inside of you. And so we know enough now that we can actually modify that and engineer it to some degree.
Are you the only people on the market doing this?
There are some other companies that are doing kind of related ideas. One of the notable ones is Day 2 out of Israel, where they're looking at what are the microbes in their gut, and if you're pre-diabetic, depending on what food you take, it'll be processed by different microbes in your gut and change what your blood sugar looks like. So there is an idea, well, can we modify the gut microbiome to resist diabetes? And so there are other companies trying to think about how do we understand your gut flora as well as your human genetic makeup to better map your response to food. In our case, we're thinking about response to probiotics and prebiotics. But there's other companies. It's kind of like the 23andMe, but a version that includes more organisms. So not just human DNA, but bacterial and viral and fungal DNA as well.
All right. And what role does this play in your 500-year plan?
So I posted on the lab's website a 500-year research plan. I will be dead for the vast majority of this plan. That's part of the plan.
Unless you've come up with a way to...
I mean, if it goes great, I'll be at least there till you're 200, maybe. We'll see. But I will likely be deceased for most of it. But it's actually an innate feature of humans that we can project a plan beyond our own lifetime. I think everyone should have at least one thing they want to do that's far exceeding their own lifetime. My plan is just to think about how we can preserve and understand human genetics, human biology, well enough to have it survive on other planets, including Mars, and surviving for the long term. I really like people. I think humans are great. We have our problems, don't get me wrong, but in general, we're the only species with an awareness of extinction, so it gives us a supreme responsibility to protect our own species as well as all others, because we're basically the shepherds for life as far as we know it. So I think we should be careful and steadfast and learning as much as we can about ourselves and then preserving ourselves and others.
And in terms of your research, what is your next step? What are you working on next?
Yeah, so we're doing additional astronauts. We're looking at other molecular changes in astronauts. We're taking some of the lessons from the genes that change in space and actually applying them to engineer cells to be more resistant to radiation as a way to test this. It's also a variation of what you can do for immunotherapy, is you can engineer T cells to go after other cells. So using some of those technologies that we're working on in lab. We've also recently partnered with WorldQuant, which is actually a quantitative trading firm, and have a fellows exchange program. So we do data modeling to think of longitudinal data or long-term data for human health, and a lot of financial traders do this for finance data and for stock market and other trends. So we have an exchange program with WorldQuant, and also trying to have a cross-fertilization of methods of machine learning in finance and machine learning in medicine, and have them come together as well.
And you also work closely with the Bill and Melinda Gates Foundation.
Yes. So the Gates Foundation has funded a project to look at the DNA of many cities around the world. So we actually have a coordinated effort of 100 cities, all swabbing surfaces of subways and mass transit systems and public surfaces. as a way to learn what's there and then what they're making. And we're simultaneously tracking antibiotic resistance as well as mining that data to find what are potential new antibiotics. So we just released some of that data online last week. And so it's very exciting because DNA sequence information holds the clues to what might be ailing you and what might be a way out of it.
And all of these, from your startup to the study to the swabbing of the public transport, are you targeting Switzerland at all here? Are you seeing any interests bubbling up here?
Yes, yeah, we have some people in Zurich that are collaborators there at University, ETH Zurich, and also at the University of Zurich. So we have we'll have a map of Switzerland that you can pop up and see where all the microbes are and which ones are in different places across Europe. So that's coming online later this year, so stay tuned. And if you've ever wondered what's on any random surface in downtown Zurich, soon you'll be able to just log in and take a look at it.
All right. I'm not sure if I'm going to look forward to that, but I have really enjoyed our conversation, Chris. Thank you so much.
Thanks so much for having me.